energy. All right. So pay attention. What is energy? So capacity to do work is called energy. Capacity to do work is called energy. All right. As simple as that. If you don't have energy, you cannot do work. Okay. So to do any kind of work, energy is required, and energy is defined as basically capacity to do work is called energy. It's a scalar quantity. It's a scalar quantity. SI unit is joule. SI unit is joule. Okay. So now the question arises is how many types of energies are there? Let us first talk about dimension also. So how many types of energies are there? Energy are of various types. Various means literally various. Okay. So many types of energies are there. In fact, this entire universe is full of energy only. Everything is energy. But we are not going to talk about all of them. We are going to talk about two types of energies which are important, and we'll be talking specifically in detail about them. So one of them is kinetic energy. One of them is kinetic energy. So what exactly is kinetic energy? What exactly is kinetic energy? Energy possessed by a body by virtue of its energy possessed by a body by virtue of its motion is called kinetic energy. Energy possessed by a body by virtue of its motion is called kinetic energy. Okay, so if an object is moving, then that object has capacity to hurt people. So what is there with the object? It has kinetic energy. Okay, suppose that objects, or you can say two cycles. One cycle is coming towards you with 1 meter per second, and that collides with you. You will say that what is this? देख के नहीं चलते हो क्या? Like that. But if the other cycle is coming with 10 meter per second and hits you, you might not be able to say something for a few seconds or a few minutes because of the pain caused or because of the accident. All right. So what is the difference between the two? The second one has more kinetic energy as compared to the first one. All right. So kinetic energy, it is the energy possessed by a body by virtue of its motion. So Ke is equal to half mv square. It's a very simple type of energy, simple expression. Ke is equal to half mv square. All right. Let me give you some questions and then you can move further. So question: an object of mass, an object of mass 10 kg is moving with 5 meters per second. Find Ke. Find Ke. Please tell quickly. Please tell. So answer is Ke is equal to half mv square. So half into 10 into 5 square. So that becomes 25 into 5 is 125 joule. 125 joule. Next question. An object of mass 5 kg is moving with velocity v vector is equal to 3i plus 4j plus 5k meter per second. Find kinetic energy of object. Find kinetic energy of object. Find kinetic energy of object. So Ke in this case will be half into m is 5 into v square, and that will be under the root of 3 square plus 4 square plus 5 square whole square. So that comes out to be half into 5. Now this is 50. So that comes out to be 125 joule. Once again, please keep your mics muted. Next question. Okay. Gauri, check your answer. So this is a block which is moving, mass is 20 kg and moving with 10 meters per second. Okay. This is A and this is B. B is moving with 5 meters per second. Question says find kinetic energy of block. Find kinetic energy of block number 1 with respect to A, number 2 with respect to B. Find. Okay. So with respect to A, answer will be KEA is equal to half into M, which is 20, into V square, which is 10 square. So that will be 1000 joule. Now with respect to B, that will be KEB is equal to half into M, which is 20. Now with respect to B, pay attention, how much is speed of block? That speed is 5. So 5 square. Answer will be 250 joule. So the point which is to be noted from this question is kinetic energy star point. Kinetic energy of an object depends on frame of reference. Kinetic energy of an object depends on frame of reference. Okay, so this is the most important learning from this question. Kinetic energy of an object depends on frame of reference. All right. So what does it mean? That means suppose there is a person who fired a bullet towards you, and if you start running with same velocity as that of bullet, then kinetic energy of bullet with respect to you will become 0, and bullet is not going to hurt you. Why? Because your kinetic energy and bullet's kinetic energy is basically your speed is same. Your speed is same as that of bullet. So kinetic energy of bullet with respect to you becomes 0. So you can hold the bullet and you can throw it just like that. You will become Rajnikant. All right. Next question. Next question. So this is an object of mass 10 kg. It is projected with 53 degree and speed of 40 meters per second. This point is A, this point is B, this point is C. P point is the topmost point. Question says find kinetic energy of mass number 1 at A, number 2 at B, number 3 at C. Okay. Okay, everyone, enough time given. KEA is equal to half MVA square is equal to half M is 10 and VA is 40 square. So 40 square will be 1600. 1600 into 5 will be 8000 joule. So that will be at A. Now KE at B. Velocity at this point will be 40 cos 53. 40 cos 53. B cos theta basically. So 40 into cos 53 is 3 by 5. So that is 24. So KE at B will be half MVB square. So half into 10 into 24 square. 24 square is 576. So 576 into 10 becomes 5760 divided by 2. 5760 divided by 2. So that becomes 2880. 2880 joule. Okay. Now kinetic energy at C. So KEC is equal to, now that will be exactly same as KEA. So we can directly write 8000 joule because A and C are at same horizontal level. A and C are at same horizontal level. So their answers will be same. Samarth, how you are getting third part as 0? Hmm? Next is potential energy. Potential energy. Potential energy. Energy possessed by a body. Energy possessed by a body by virtue of its position, configuration, energy possessed by a body by virtue of its position, configuration, or shape is called potential energy. Okay. Energy possessed by a body by virtue of its position, configuration, or shape is called potential energy. Mr. Vedant, if you are saying but at A and C velocity is 0, then how it is going up? If at A velocity is 0, then how the object is going up? Tushar noted. Okay. So potential energy, energy possessed by a body by virtue of its position, configuration or shape is called potential energy. Suppose you are sitting on a chair, you must be sitting on one or anything. Now if you jump from that, the height from the ground is very less. So the energy, or you can say which you possess right now, is lesser. Okay. So when you are going to reach the bottom or ground, you will feel no pain actually. But if you jump from first floor, okay, you will feel more pain. Why? Because energy possessed now is more as compared to earlier. If you jump from second floor, pain will be even more. If you jump from third floor, there will be instant pain, and after that there might be no pain. Correct? So what is happening when you are changing floors? Your energy possessed by virtue of position is changing. Your position is changing. All right? So that type of energy is potential energy. In this case, if you want to talk specifically, it is gravitational potential energy which is changing. It is gravitational potential energy which is changing, right? So that is changing every time. Now comes configuration. What do we mean by that? Suppose we have three charge particles, Q, Q, Q. Let me call same. So these three particles are kept like this. They will have some energy. Now if you keep these charge particles like this in a different configuration, this was A, B, C. Now it is A, B, C, Q, Q, Q. So their energy will be different in second case. Okay, so what has been changed? Configuration has been changed. What has been changed? Configuration. What has been changed? Configuration. So energy possessed by a body by virtue of its position we have talked. Configuration also we have talked. Okay. Now you must have seen people using bow and arrow, or let's say spring. So when you compress the spring and release it, it jumps, right? Why it is jumping? Because when you have compressed it, some energy has got stored in it. That energy has got stored in it due to the deformation caused by you or by someone else, right? So that is due to change in shape. That is due to change in shape. Okay. So the energy which is possessed by a body by virtue of its position or configuration or shape is called its potential energy. Okay, is called its potential energy. All right, all right. Potential energy is always associated with some force. Potential energy, potential energy is always associated with some force. Okay, potential energy is always associated with some force. Now what is meaning of potential energy associated with some force? See, without force potential energy cannot exist. Without force potential energy cannot exist. That's the meaning of potential energy being associated with some force. For example, if you remove gravitational force from the universe, then gravitational potential energy will not exist. If you remove gravitational force from the universe, then gravitational potential energy will not exist. Okay. If you remove spring force from the universe, then spring energy will not exist. If you remove electrostatic force from the universe, then electrostatic potential energy will not exist. All right. So for any potential energy to exist, there is a force acting in background. There is some force in the background due to which potential energy is existing or it is defined. All right. Okay. So potential energy is always associated with some force. So based on the force associated, potential energy potential energy is also defined and classified. Okay. So what expression of that potential energy will be? Who is going to decide? The force. Okay. So if you change the force, expression will change. The name also will be changed based on that. If you are talking about gravitational force, then the potential energy will be called gravitational potential energy. If you are talking about electrostatic force, then the potential energy will be called electrostatic potential energy. If you are talking about spring force, then the potential energy is called spring energy. All right. So based on the force associated, potential energy is also defined and classified. One more important point. Potential energy, potential energy is always defined, always defined only for conservative forces. Potential energy is always defined only for conservative forces. This point is important. Conservative forces. What do we mean by conservative forces? Okay, we need to look at this. So suppose there is an object, this point is A, and you are taking that object from A to B. Now you can take that object directly, you can take that object on this path, or you can take that object on any other path. Okay, so this is path 1, this is path 2, and this is path 3. This is path 3, right? So if the force is conservative, then whichever path you take it, work done will be same. Okay. So what are conservative forces? Let us talk about them. What are conservative forces? Let us talk about them. So conservative forces are the forces, conservative forces are the forces for which work done, to shift an object, from one place to another, another does not depend on, path followed, does not depend on path followed, but only on initial and final position, but only on initial and final position. Okay, so basically when you are taking that object from A to B, so the work done is not dependent whether you have taken it from one path or second path or third path. In all the paths, work done will be equal. So W1 is equal to W2 is equal to W3. This is the meaning of force being conservative. This is the meaning of force being conservative. Okay. This is the meaning of force being conservative. Is that clear? Good. Good. Now you can define it in a different way. Second definition.
if work done in a closed path is 0, if work done by a force is 0 in closed path, okay, if work done by a force is 0 in closed path always, okay, then the force is called conservative force. Then the force is called conservative force. So what is the criteria? Work done in a closed path has to be 0. Work done in a closed path has to be 0. Okay. If work done in a closed path is 0, then the force will be called conservative. If work done in a closed path is 0, then the force will be called conservative, otherwise not. Okay. Any doubt, any question? Good. Good. All right. So let us talk about gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Okay. So energy associated with energy associated with gravitational force. Energy associated with gravitational force is called gravitational potential energy. Energy associated with gravitational force is called gravitational potential energy. Energy associated with gravitational force is called gravitational potential energy. Okay. Now just to understand, okay, we are taking example of Earth mass system. We are not taking point masses here. We are only talking about Earth mass system, and we are going to talk about its potential energy. So let us see. So suppose this is Earth surface, all right, and this is some object M. Okay, mass of object is M. Now if we want to know that how much is the gravitational potential energy of M with Earth, all right, so gravitational potential energy GPE of mass M with Earth, GPE of mass M with Earth is given as so U, potential energy is shown by symbol U. So U is equal to mgh. U is equal to mgh. Okay. Now the question arises is, the question to be asked is, how much is the value of h, or from where the h is to be measured? Okay. So be very clear. here H is measured. Here H is measured from reference line. Here H is measured from reference line. This is very important. Okay. So from where you are measuring H? From reference line. Alright. So here H is measured from reference line. Now what is a reference line? Okay. What is a reference line? So reference line is the line at which GPE is assumed to be 0. Okay. GPE is assumed to be 0. The very important word is assumed. Okay. We are assuming that gravitational potential energy is 0 on the reference line. In reality, is it 0? We don't know. We don't want to know. We just want to know that at which point gravitational potential energy is 0. Please tell us. Why we are finding that? Because based on that, we can find our answers. Okay. Now, is that any criteria that your reference line should be on Earth's surface? No. You can choose any line as the reference line as per your convenience. Okay. We can choose or let's say, let me add one more word, unless specifically mentioned. अगर क्वेश्चन में ऑलरेडी मेंशन्ड है तब तो अलग बात. So unless specifically mentioned, we can choose any line as reference line as per our convenience. Okay. So we can choose any line as reference line as per our convenience. Okay. All right. Good. Now let us see what is happening to the Earth surface and mass m. So what I am doing, I am considering this line as reference line. So if this line is reference line, then I need to find height. So this is h, and now you can easily tell the gravitational potential energy of block M, and that will be U is equal to mgh. All right, mgh. Okay. Okay. Let us move further. Question. So this is ground, and this is a block of mass 10 kg. Okay. This height is given as 10 meters, and then there is ceiling, and this height is given as 5 meters. Okay. Let me call this point as A, and let me call this point as B. So the question says find GPE of block if number 1, reference line is at A, number 2, reference line is at B. Okay, so you need to find the gravitational potential energy of block when first case when reference line is at A, Second case, when reference line is at B. Please find. Oh. Okay, everyone, please pay attention. In fact, let me do it here. So, with respect to A, so UA is equal to MGH. M is how much? 10. G is how much? 10. H is how much? 10. So this becomes 10, 10, 10. This becomes 1000 joule. So UA, potential energy with respect to A, becomes 1000 joule. Now with respect to B, so with respect to B, if you see, so UB is equal to MGH, and if you want to add, you can call HAHB, like that, just to make it different. Otherwise people will say, sir, you are writing MGH at both places, just to distinguish between the two. So M is 10, G is 10, H is -5. Be very clear, because with respect to line B, block is below the line, below, right? So this comes out to be -500 joule. Any doubt, anyone? Any doubt, anyone? Any question? Any doubt, any question? No doubt, no question. Very nice. Very nice. Now I'm giving you another question. IPQ. IPQ. If block falls on ground, if block falls on ground, find change in GPE of block number 1 with respect to A, number 2 with respect to B. So you need to find change in GPE of block. You need to find change in GPE of block. So Suhas is saying minus 1500. Kapil is saying minus 1000, minus 1000. What is this? Pratyusha is saying minus 1000 and 1000. Deepika is saying minus 1000, 1000. Christy is saying plus 1000, minus 1000. Sandesh is saying minus 1000, plus 1000. Ramchandra is saying minus 1000, plus 500. So many people, so many answers. Very nice. India is a diverse country. Okay. Now, pay attention, everyone. Pay attention, everyone. UA initial is 1000 joule, right? Now, when it will fall, so UA final, so it has fallen to the ground. So MGH final, so 10 into 10 into 0. That's why it is 0. So delta means change. So change of anything is always final minus initial. So delta U means U final minus U initial, and that will be 0 minus 1000, and that will be minus 1000 joule. That will be minus 1000 joule. So delta U with respect to A is minus 1000 joule. All those who have got delta U as minus 1000, they can pat on their backs. Okay. Okay. Now let us talk about with respect to B. So UB final. Now pay attention. If it has fallen, how much it has fallen? It has fallen a lot. So MGHB final. M is 10, G is 10. This is minus 15. Minus 15. So that comes out to be minus 1500 joule. UB final. So delta UB will be UB final minus UB initial or UB, right? So minus 1500 minus 500, and that comes out to be minus 1000 joule delta U. So delta U comes out to be minus 1000. So this, first of all, you all should be very clear that change in potential energy in both the cases will be same. Change in potential energy in both the cases will be same. Mr. Chirag, pay attention. Vedant, pay attention. Shivangi, pay attention. Suhas, but finally, sir, H is equal to 0. Yes, I have also used that. But check your reference line. Check your reference lines also, Mr. Suhas. Okay. Pratyusha is saying, sir, oh, I wrote oof. Okay, it is UF. Okay, all right. Change is always final minus initial. When you meet someone after a long time, you say, yeah, you have changed a lot. So how you are saying? Because you are comparing the person right now from the previous time. So change is always final minus initial. Change is always final minus initial. Remember that. Okay. So the point which I wanted to tell you is, listen very carefully. Potential energy, potential energy of an object depends on depends on reference line. Potential energy of an object depends on reference line. That is true. But change in potential energy does not depend on change in potential energy. Change in potential energy does not depend on reference line. Understood? Try to understand and visualize significance of this. Okay? Try to understand and visualize significance of this. You are sitting and studying right now, right? So suppose by chance the fan which is at the ceiling right now, okay, if that fan falls on your head, if then that fan falls on your head, obviously that is going to cause some pain. Okay, now the pain caused by fan will not be dependent on that what you have chosen as your reference line. The pain caused by fan will not be dependent on choice of reference line. You can't say, wait, I'll make the pain caused by you as 0 by changing the reference line. I'll calculate the pain, or I'll do the calculation in such a way that pain will become 0 if I select this as reference line. No, it is not going to happen. In fact, fan is not at all interested in your reference line. It is only interested in causing the pain to you, right? And it will independent of whatever you take as the reference line. It will come and hit your head and give you a very good experience. All right. So the point which is to be noted is potential energy of an object depends on reference line, that what you have chosen as reference line, but change in potential energy does not depend on reference line. Change in potential energy does not depend on reference line. Very nice. Deepika is saying दिन में तारे नजर आएंगे and she is showing 2 stars also. Ronald, if I am sitting on the fan, then pain is equal to 0. No, Ronald. First of all, you should not do such stupidity like monkeys. But even if you are doing that, when the fan is falling, you will fall with the fan, and that will cause the pain. Okay? Okay. I was not aware actually that you do that. Why do you do that, Ronald? Hmm? Why do you do that? Okay. Next time when you are there, send some pics also. So the point to be noted is, pay attention back to the topic. Potential energy of the object of an object depends on reference line, right? And change in potential energy does not depend on reference line. Now, one very important thing, everyone please pay attention. The whole world actually works on change of reference or change of potential energy basically. It does not depend how much potential you have, how much change in the potential energy is caused, and that will do the whole thing. Okay, the whole world works on the basis of change in potential energy. Okay, the important part is change in potential energy. Okay, Asmita is trying to be detective. Pay attention everyone. Question. This is a block. M is mass, L is length, okay, and it is uniform block. Uniform means mass is uniformly distributed. Your reference line is on ground. Reference line is on ground. Question says find GPE of block. Find GPE of block. So basically your block is in shape of a bar, or you can say rod. Please solve. Srishti is saying changing the reference line also means that you are changing H, right? Obviously, if your reference line is changing, then height will change. Otherwise, what is the point of changing the reference line? Samarth is saying MGL by 2, Suhas is saying MGL by 2, Chrisley is saying MGL by 2, Srishti is saying then potential energy will change, right? She is still there, yes. Using COG. What is COG here? Suhas, COG. Ronald is saying MGL by 2 with a question mark. That means he is trying to... Oh, center of gravity. Ronald is saying center of mass. All right, all right. Different people are trying to be differently smart. All right, pay attention, everyone. Now, in this question, the problem is that the object is not a point mass. So, if object is not a point mass, which height is to be taken? Can I take point A as the height? Can I take point B as the height? If I take height of point A as the height of object, then potential energy will become zero. And that also means that I am treating object as a point mass, which is not correct. If I consider point B as the height, that means potential energy will be mgl. But that also means that I am considering this object as a point mass, which is also not correct. So I should not do all these things. So what should I do? I should, focus on physics, right? And how I can focus on physics? Pay attention. By applying the concepts of physics properly. How I can do that? I can consider some point mass in the block. So what I am doing, I am going at some height y and considering an element of length dy. Now as dy is very small, that can be treated as a point mass, and let us say mass of that is dm. So for that very small element, it is very, very, very small. The potential energy will also be very small. So for the chotu element dm, potential energy will be small, and that is du. and that will be nothing but dm, because that is the mass of the element, into g, because that is g of the g, and h is y here. H is y here, right? But the problem is, what is dm? We don't know. Y is also variable. You cannot leave answer like this. I said yes, I know that. So pay attention. In L length, mass is m. It is given in the beginning itself. So in unit length, mass will be m by L. So in dy length, mass will be dm, and that will be m by L into dy. That will be m by L into dy. So du comes out to be dm is m by L into dy into g into y. Okay, so du comes out to be mg by L y dy. Du comes out to be mg by L y dy, right? So u will be integration du, will be integration y dy, because rest of the things are constant. Now the only thing which is left is how much will be the limit, or what will be the limits. So your first element you are getting at L is equal to 0, and last element you are getting at y is equal to L. Okay, so your entire rod or block is within 0 to L. That's why your limit is going from 0 to L, right? When you are taking element, let me show you how your limits are going from 0 to L. From here to here. This is the first point. So which is y is equal to 0. This is the last point, which is y is equal to L. Okay. That's why it is from 0 to L. So u is equal to mg by L. Integration y dy will be y square by 2. Limit is from 0 to L. And when you are going to put all these limits and everything, you will get mg into L by 2. Okay. And that can also be written as m into g into hcm. This is height of center of mass, not center of gravity. Okay, Suhas, it is center of mass, not center of gravity. Okay. So basically, this tells us a very simple but important thing, that height, or you can say center of mass of a uniform rod is at its midpoint, because L by 2 means midpoint. So what is happening ultimately, let us now understand or summarize that for the calculation of potential energy purpose, this rod is behaving as a point mass kept as L by 2. For the calculation of potential energy purpose, this rod is behaving as a point mass kept at L by 2. Any doubt, any question, anyone? Any doubt, any question? Yes, no? Nobody is asking anything. Good. Good. Next question. And this time also there is a rod. Okay. So for this rod, things are slightly different. Lambda is equal to lambda naught x. Okay, what is lambda here? Length of the rod is L. This point is A, this point is B. So for a rod, mass per unit length, lambda is equal to lambda naught x. Okay, here x is distance from and B. Okay, lambda naught is a constant. I am not writing that. So for a rod, mass per unit length is given as lambda is equal to lambda naught x. Here x is distance from and B. Question says find GPE of rod, and your reference line is surface only. So reference line is also given. Bottom is the reference line. Please solve. Ronald, your question is not even worth answering. Suhas is saying lambda into G into L cube by 3. I don't know. It could be right also. See, Ronald, if it is distance x, obviously it will be for the entire rod. What is M here, Suhas? Hmm? How have you substituted lambda by M? Hmm? How have you substituted lambda by M? We have never given what is M in this question. Okay, let us not waste time. Pay attention, everyone. We are going at a distance y from the bottom. Bottom is point B. And taking an element of length dx. Suppose dm is the mass. So if it is not given, how you have created m? So if du is the element energy, so du will be dm into g into y. Why did you do that? Why? So dm, pay attention. This is equation number 1. How much is dm? So dm will be lambda into dx, because lambda is mass per unit length and dx is length. Just a second. When y is the variable, so this should be dy. Okay, so this will be lambda dy. Lambda dy. Now how much is lambda? Just a second. This is given as lambda naught x. Uh, Basically, so let me take this as dx to maintain uniformity. This as x. Now this as x. So lambda is lambda naught x into dx. Okay. Lambda is lambda naught x into dx. All right. So now this is equation number 2. So from 1 and 2. From 1 and 2. So du is equal to dm is lambda naught x dx into gx. So lambda naught into g into x square dx. So much is happening in the universe. So u is equal to integration du is equal to lambda naught g integration x square dx, and limit is from 0 to L. Alright, so today we get the answer as u is equal to lambda naught g L cube by 3. Okay, and then somehow Suhas converted that something something into m. I don't know how. Okay, I don't know how. Understood everyone? Understood everyone? Any doubt, any question? Any doubt, any question? Okay. Next question. Next question. Question? So this is a frame. All right. And then there is a chain. There is a chain. What type of chain? Uniform chain. Uniform chain. So M R uniform chain, and this is reference line. This is reference line. Okay. So there is a uniform chain which is kept over a hemispherical shape. Okay. So chain is linear basically. That's why it is chain. What you need to do is you need to find GP of chain. Find GPE of chain. Find gravitational potential energy of chain. Okay. Suhas is saying 2 mgr upon pi. Samarth is saying 2 mgr upon pi. Pooja is saying 2 mgr upon pi. Ronald is saying mgr upon pi. Very nice. People are doing it in double of that. Ronald did it for half. Good. That is called efficiency. But it should be correct also. Pay attention, everyone. Pay attention. So what we are doing here, we are going at an angle theta and taking an element of length d theta. We are going at an angle theta and taking an element of length d theta. Okay. Suppose dm is mass of this, then du. So du will be nothing but dm into g into h. What is h here? H is basically height of this chain or that small element with respect to the reference line. So h you can see is nothing but r sine theta. H here is nothing but r sine theta. Okay. Okay. So du is equal to dm into g into h, and h is r sine theta. Now how much is value of dm? So pay attention. In total angle, how much angle we are going to rotate? We are going to rotate pi. So in pi angle, mass is m. So in unit angle, mass will be m upon pi. So in d theta angle, mass will be dm, and that dm will be m upon pi into d theta. So that is the value of dm. So from equation 1, so du comes out to be dm m upon pi into d theta into g into h is r sine theta. Okay. So u will be integration du is equal to mg r upon pi integration sine theta d theta, and your limits are from 0 to pi. Your limits are from 0 to pi. Okay. So u comes out to be mg r upon pi. Integration sine theta d theta will be minus cos theta, and limit is from 0 to pi. So mg r upon pi. Now minus can be taken out. Cos pi minus cos 0. So when you summarize this, it comes out to be u is equal to 2 mg r upon pi, or we should write it as u is equal to mg into 2r upon pi. So basically it tells you that height of center of mass of half ring is 2r upon pi. Okay. So basically this can be used as a method to find the position of center of mass. This can be used as a method to find height of center of mass. So answer is 2 mgr upon pi. Ronald and Gauri, please correct your answers. Okay. Next question. I hope you all have noted. You all have noted. Please keep your mics muted. Please keep your mics muted. Thank you. Okay, next question. So this is a chain, uniform chain. Okay, m is mass, r is radius as it is. Your reference line is this. Question says find GPE of chain. Find GPE of chain. Pooja is saying minus mgr upon pi. Has the mass gone below the reference line, Pooja? If the mass has gone below the reference line, then only your answer can be negative. If mass is above reference line, your potential energy has to be positive. Then think about it. Just to tell you all, your answer will be exactly same as previous question. Just to tell you all. Okay. Your answer will be exactly same. Limits will be changed and the factor of mass. Now this time the angle will be pi by 2. You should solve all of you should solve this. All of you should solve this. Your answer will be exactly same. Okay. I want all of you to solve this and show the answer in chat box. Okay. Send me your answers in the chat box after you solve this. All right. That is enough for today. We'll study further in next class. Thank you so much.